All right, let's look at problems 15 through 19 really quickly. 15 states, if you have a wrench and you apply a 34 Newton force to the wrench perpendicular to the wrench and you apply it 0.13 meters from where the bolt is attached, it's a simple torque problem. Torque is equal to force times radius. Here's your force, here's your radius. 4.4 Newton meters is your answer. Number 16, if you take the same wrench but you apply the force up here, still 34 newtons, but you do it at a distance of 0.25 meters, we do the same problem as this one here, except it's going to be 34 newtons times 0.25 meters is equal to 8.5 newton meters. So the farther you grab the wrench from where you're, from the nut you're turning it on, the greater the torque you're going to have. Number 17, you plant the tip of a shovel into the ground. The shovel is 1.8 meters long. You apply 145 Newton force perpendicular to the shovel. It's simple. Torque is equal to force times radius. And here's your answer. You have a nail that's in the board. You take a crowbar and you're trying to lift up on that nail, or you're trying to pull down the nail, depending how you want to use that crowbar. Still same thing. It's a torque problem. Torque is equal to force times radius. Here's your force. Here's your radius. That's your answer. And then problem number 19, you have a door and you're going to be pushing on the door with a 45 Newton force, so the door is going to swing on its hinge. You're pushing on the handle, which is 1.2 meters from the hinge. Once again, simple torque problem. Torque is equal to force times radius. You're pushing with a force of 45 newtons, 1.2 meters from the hinge, from the pivot point, and your answer is 54 Newton meters.